Before I introduce today's guest, I want to tell you about our one and only sponsor or advertiser. It's the Great Courses Plus. It's an app on your phone. Looks like this. For those of you watching, you just touch the app. It opens it up. And the access to hundreds of courses and therefore thousands of lectures is available for a monthly fee. If you subscribe through my podcast, that is, you go to thegreatcoursesplus.com/salon, you get a free trial. And therefore you have free access to hundreds of courses and therefore thousands of lectures. Just to give you an idea, instead of focusing on one particular course that I've been listening to, just to give you a little bit of a sampling, great ideas of psychology, philosophy and physics, the dark side of human nature, the pagan world, the Pacific Theater in World War II, white-collar criminal law, U.S. government, mind-blowing science, this day in history, September, recording this in September 2020, Apollo 11, everyday guide to beer, everyday guide to beer, Battlefield Europe, infectious diseases, a field guide to the planets, the science of extreme weather, what we know about the Big Bang, and on and on and on. Literally, just hundreds. You just scroll through. And the beauty about this app, thegreatcoursesplus.com/salon, is that instead of purchasing a single course and then feeling like you need to listen to all the lectures, maybe you don't want to listen to all the lectures. Maybe you just want to do a sampling, which is pretty much what I usually do. So give it a try. It's, again, you go to thegreatcoursesplus.com/salon. Thanks for listening. My guest today is Dr. Paul Halpern. His new book is Synchronicity, the Epic Quest to Understand the Quantum Nature of Cause and Effect. Paul is a professor of physics at the University of the Sciences in Philadelphia and the author of 16 popular science books, including The Quantum Labyrinth and Einstein's Dice and Schrodinger's Cat. He lives in Philadelphia. His book is really super interesting, talks about all the big questions about the nature of cause and effect and causality. And so we get into discussing that and starting off with model-dependent realism, the idea by Stephen Hawking and Leonard Mlodinow that we're not marching ever closer to a perfect theory of everything, that in fact it very much depends on the model you're using and how predictable the models are and so forth. And so from there we branch out to talking about quantum physics and what that did to previous ideas of cause and effect in science. And then we talk about Jung and synchronicity and Wolfgang Pauli's flirtations with the paranormal and the supernatural, and J.B. Rhine's lab studying extrasensory perception and where that led in the 1950s. And from there we talk about, the big questions: free will and determinism, the origins of the universe, the multiverse, archetypes, Jung's idea that we're all interconnected through this collective unconscious, and what science says about that, or at least what physics says about that. And then we conclude talking about spirituality and what that means to be spiritual without being religious in a scientific sense. So with that, I give you Dr. Paul Halpern. Hi, Paul. Thanks for coming on the show. Congratulations on the new book.
Hi.
Here it is. I'll show it to our guests who will have already seen the link to it and how they can order it. Synchronicity, the Epic Quest to Understand the Quantum Nature of Cause and Effect. Basic books. Beautiful cover. Love the book. I listen to it on audio as I do so many of my guest books. And interestingly, this week, the week we're speaking, we're recording this the week of September 8th, I dropped the podcast I did with Leonard Mlodinow. And his memoir of Stephen Hawking, what it was like working with him, particularly their book, The Grand Design. So I thought I would start, because so much of your book, about half of your book, is history of science, which I love because I'm a historian of science. And I've always thought of science as this kind of asymptotic curve toward truth. We're never going to get there because we're not omniscient, we're not deities, so we'll never know for sure. But I always picture it as this curve that's, kind of approaching reality. So I presented that to Len because I knew how he's a longtime friend, and I knew how he was going to respond. He said, no, I absolutely reject that. Stephen and I presented model-dependent realism. So you're probably familiar with this. For our guests who are not familiar with it, here is the quote from Hawking and Mlodinow. Now, this is from their book, The Grand Design, and then you and I can key off of this. In the history of science, we have discovered a sequence of better and better theories or models, from Plato to the classical theory of Newton to modern quantum theories. It is natural to ask, will this sequence eventually reach an endpoint, an ultimate theory of the universe that will include all forces and predict every observation we can make? Or will we continue forever finding better theories, but never one that cannot be improved upon? We do not yet have a definitive answer to this question. And so reading your book, you can't help but get the sense that we are getting better. The models really are better. Better than what? Well, better than the previous ones, as judged by what? As some kind of sense that there's a real world that's there and we're understanding it better. Your response to that?
Well, I think the models are getting better from the point of view of improving upon our existing theories. For example, general relativity is amazingly accurate in terms of predictions, and quantum mechanics, particularly quantum field theory, is amazingly accurate in terms of its predictions. But then the question is, how do you unite the two? And aesthetically, we would like to have a theory of everything that combines general relativity with quantum field theory and be able to explain general relativity in terms of the quantum. But what if that's impossible? Well, aesthetically, we would like to see one theory, but it could very well be possible that there are several theories describing the universe and that they're irreconcilable, that we can't really unite them. And then we would have to kind of stop and say, well, general relativity, we just have to conclude that it's a perfect theory. It doesn't have any quantum aspects, but that's it. And that's the way it seems. Every experiment testing general relativity has shown that it's 100% accurate so far. And we keep trying to find some flaw in general relativity that would open up the way for quantum gravity, but we still haven't found any discrepancy, which is pretty remarkable for general relativity, pretty remarkable for Einstein. And I'm sure Einstein must be kind of, if he were around, laughing right now, saying, look, ultimately my theory stands its ground and has nothing to do with the quantum.
Yeah.
And that this is disturbing for some people, but for other people, particularly classical general relativists, are very pleased by the results so far.
Yeah. I see you have Walter Isaacson's biography of Einstein there. I was just binge watching the Hulu.com series, or maybe it's on Netflix. No, I think it's Hulu. Genius, the 10-hour Einstein drama, just a dramatization. And they really there's that moment where, he says he realizes Newton was wrong, but we would not think of, or would you characterize general relativity as showing that Newton was wrong, or that Newton was right at his level of analysis and Einstein just improves upon that?
Well, Einstein was very radical in some ways and very conservative in other ways. So it's interesting to look at both aspects, because it's pretty remarkable that Einstein threw out absolute space and time. Everybody believed in absolute space and time, and in trying to explain the fact that light moves at a constant speed, the physicists in the past introduced things like the ether and so forth, which turned out not to be right. And Einstein said, let's reject that, reject the ether, but then we're also going to reject absolute space and time. And this was absolutely remarkable, because it seems almost a given that space is constant and that time is constant. And then Einstein said, no, they're flexible, they're malleable. And he made the theater of physics something with a malleable stage rather than a constant stage. So the stage is part of the drama. On the other hand, Einstein believed very solidly in Newtonian determinism. He believed that everything followed from a first cause, and things just kept going in a clockwork manner. And that turned out not to be the case, that not everything is determined by strict cause and effect. He also believed strictly that everything is local. General relativity, special relativity, all take place at a particular point in space. And you just consider what happens to the neighbors, what happens to things that surround you. And that's not true in quantum physics. In quantum physics, you can have something that's miles away and still that's somehow connected with you. And if something happens to that thing, then something also happens to yourself.
Yeah, it's an interesting kind of sociology of science exercise to see how long it took Einstein to convince his professors when he was a graduate student, then his colleagues, and then they finally come to accept him. Maybe that's an entire process, maybe 15 to 20 years before he becomes world famous. And then after that, say the next 30 years of his life, he's the dogmatist and the flatlander, the old guy that can't accept the radical new ideas. It's funny how that operates psychologically.
Yeah, it's funny because Einstein had a very good friend, physicist Paul Ehrenfest, who was an Austrian physicist who moved to Holland and questioned a lot of things. He was a very big skeptic, a questioner of knowledge, and always asking good questions at seminars. But then he said to Einstein, look, in the past, people challenged you and you were the radical, you were the revolutionary, but now you've become the conservative. Why can't you just accept that quantum physics is real? And Einstein had no response to that. And Ehrenfest was always dismayed because his two best friends were Einstein and Niels Bohr, and he could never get the two of them together to see eye to eye.
How weird was that for the exercise of thought experiments for, I don't know what, setting up future experiments to see if it's true or not, but just the idea of kind of an armchair, I'm imagining riding on a beam of light, or I'm imagining falling through an infinitely long elevator shaft and everything is floating there, so that's gravity. Or the two beams of light hitting simultaneously when you're standing on a stationary hillside, but if you're on the train moving, the one lightning strike will happen before the other one. How can that possibly be? That was just brilliant. But that's not enough, right? You got to have some kind of experimental test.
Yeah, well, the early 20th century was the great age of thought experiments. It's pretty remarkable that so many thinkers can come up with conclusions and leaps of intuition based upon just thinking about things or dreaming about things. And Einstein was certainly the king of that in terms of coming up with experiments that led him to radical conclusions, such as, trying to chase a beam of light or falling in an elevator and seeing what happens if you also drop something at the same time. So Einstein was great in terms of his intuition, but ironically, in Einstein's later years, a lot of the stuff he did to try to unify gravity with another force, with electromagnetism, was very unintuitive. And he opened himself up to a lot of criticism then, because starting in the 1920s, Einstein stopped fully believing in his own theory of relativity and thought it had to be modified to take into account electromagnetism. And that was a great idea, but then every theory he came up with to try to combine the two was completely unintuitive, added some extra elements that were unnatural and could not be tested experimentally. So he started to become this abstract theorist that he derided in the past. In his youth, he wanted everything to be tangible, but then in his middle age, he kind of said, well, wait a minute, let's just go with the mathematical. Let's go with what looks beautiful equation-wise. And he completely changed his outlook on things. And he met with a lot of criticism. And as I show in my book, Synchronicity, Wolfgang Pauli, who was an Austrian physicist to be considered in some ways a successor to Einstein, was constantly criticizing Einstein and saying, well, your new theories do not meet the test of general relativity. What are you doing there? Why are you coming up with theories that do not match experimental predictions?
Yeah, here I'm kind of asking in the context of the kinds of letters I'm sure you must get far more than me, which is these, I call them theories of everything. These are from amateur people. They have no training or whatever. They're almost always guys. They're all guys. And, I've been working on this theory. Newton was wrong. Einstein was wrong. Feynman was wrong. Hawking was wrong. And I figured it out. And it's usually physics and cosmology for some reason. And I always encourage them to check with the local high school physics teacher in case that's already been worked out centuries ago, or, something is really simple, because I'm not a physicist, but you must get those. So, and of course they think of themselves as like Einstein. Well, he did thought experiments. I'm just doing thought experiments. So my point is, at some point, you can't just think about it. It has to be testable in some way, falsifiable. There has to be some way to get at it, that it's not just, just a wild ass guess you've made.
Yeah, that's true. There's a lot of people come up with these ideas. I think in two areas, people think that they know more than the experts, or at least two areas, physics and psychology. Yeah. A lot of people try to come up with psychological theories. But my wife is a psychologist, and she's always emphasized testing and experimentation and so forth. But then there are people who just have hunches. And the same thing about physics. People say, well, I have a feeling that there are higher dimensions.
I have a feeling, right.
Don't necessarily have proof. But people think that they can unravel things that other people couldn't unravel. But Richard Feynman, great physicist, was once asked about starting new journals that would allow for people on the fringe to publish things and so forth. And he said, look, in his experience, everything that was worthy of publication eventually found a place to be published. That he thought it was a myth that there are all these works out there and that they're rejected arbitrarily. In fact, there's so many journals in physics these days, and there are major journals, minor journals, online journals that practically need very little refereeing, or they're refereed, but the criteria are not super strict. If somebody has something that's reasonable, they'll be able to get it published somewhere. Yeah. So if somebody says, "Oh, look, I'm being rejected because I'm this rebel and everybody's against me," that's probably not the case. They should try somehow to publish things. And then even if you can't find a place to publish, there are contests which are open to the general public, saying, come up with your abstract ideas or your intuitive ideas about the subject. And those are possibilities. So really everything has a way of being published that's reasonable, that's thoughtful.
I think so. I agree with that. Part of the replication crisis problem is the so-called file drawer problem, in which we don't get to hear about all the failed experiments and bad ideas because journals are not interested in publishing those, which is itself a problem. But so for all the kind of fringers out there, alternative physics people or whatever you want to call them, they don't know about all the failed experiments and bad ideas. That even most scientists, most of their ideas are crazy and wrong. And the ones we hear about are the successful ones. So you read about Galileo and Einstein and so on. You don't hear about the 10,000 other people that had ideas that just never panned out. And it wasn't because they were discriminated against or censored or anything like that. They were just not productive ideas.
Well, that's the wonderful thing about history of science, because sometimes it brings up alternative theories that were rejected. For example, in my book, Synchronicity, I show that Pauli became obsessed with the conflict between Johannes Kepler and an astronomer named Robert Flood, who came up with a very different theory of the planets. It was not a heliocentric theory. Earth was at the center, but he came up with this model. And Pauli was kind of interested in it from a cultural point of view and from a kind of a point of view of the symbolism of it. Because Pauli, when he started to interact with Carl Jung, he began to become interested in mythical ideas as well as scientific ideas. He was interested in how archetype, which is a concept coined by Jung to describe cultural memes, cultural aspects that are shared by a lot of groups. Pauli was interested in how that might have affected the conflict between Kepler and Flood. So it was kind of interesting that some physicists sometimes are open to ideas that are rejected just from the point of view of trying to study history and to see why some ideas succeed and some ideas fail.
Yeah, you have a discussion of Tycho Brahe's alternative model where the sun is the center of the planetary system, but that whole thing goes around the Earth, so we're still stationary. Of course, that never went anywhere presumably because it's not right. It's incorrect.
Yes.
and there's lots of those in the history of science. And of course, most people don't know about them. So I love that you spent a lot of time on the history of this field. A couple of things while I've got you here, because when I was thinking about reading your book, what does it mean when we say, the universe is mathematical, or what and where are laws of nature? When you say, well, that's a law of nature, there's no laws out there. These are human constructs, right? But maybe mathematics is not strictly a human construct. It's maybe a Platonic ideal that's out there somewhere. How do you think about those big issues?
Yeah, it's very interesting to think that, if nobody discovered pi, would it still be out there?
Right.
And there's certain mathematical facts that seem fundamental that somebody would be bound to discover them. In fact, in the 1970s, the mathematician Mitchell Feigenbaum came up with a constant based upon using his calculator and trying some calculations to see how quickly something goes to chaos, complete randomness, or apparent complete randomness. And he came up with his own constant that apparently hadn't been discovered before because the calculator hadn't been invented, the pocket calculator. The people weren't really trying out these things, and he came up with a constant. So people can find these things, and some of the laws of nature though seem either intuitive or seem so basic that they seem very fundamental, and that I think they would have been discovered. There's sometimes when something seems intuitive, but it turns out to be false. For example, Aristotle came up with this idea that if you apply a force to something, it moves. Yeah. And anytime you apply a force, it moves. But then later, as Newton showed, things move on their own, that you have to apply a force to change the motion, not to actually make something move. But for millennia, people believed in the idea that if something moves, you need a force to move it. And that was a huge change when they realized that things can move through space on their own without any forces, and that the concept of force is in some ways extraneous. It's to get something to change the motion.
Although presumably something must have pushed it in the first place. There had to be a prime mover, so to speak, a big bang, whatever.
Well, that is if you believe in absolute space.
Oh, okay.
Something must be making it move relative to absolute space. If you don't believe in absolute space, then all motion is relative. So if something is moving, it's just the same thing as being at rest. You can't even distinguish them.
Well, I mean, we often think of gravity as a force that's pulling things toward it, such that if I drop something, it falls, or have my little globe here, but according to Einstein, it's just, if something goes near this massive object, it's sort of falling around it. It's not being pulled toward it. So it's not a force like magnetism. But at this point, I'm out of my league here. How do you define what is gravity? You can't just say it's the tendency of objects to attract one another. Why do objects attract one another? Because of gravity.
Well, it's funny. The Newtonian picture of gravity was fundamentally flawed because it involves something called action at a distance. So Newton said there was an invisible thread linking all massive objects. So the sun and the earth are tied by an invisible thread. So theoretically, if you cut the cord, Earth should immediately start flying away from the sun. Well, that turned out to be wrong because every interaction, according to Einstein, must happen at the speed of light or slower. So that means that if the sun suddenly blinked out, that Earth would not immediately know to move in a straight line, but rather would have to wait 8 minutes until the signal from gravity reaches Earth. Well, if gravity is a signal, signals are like waves. They must travel through something. And that's one of the reasons Einstein came up with the idea that gravity is a disturbance, and that it's actually, gravity is a ripple in the fabric of space and time, that space and time unified form this kind of fabric, and that if you place a massive object, you're distorting the fabric, kind of like you took a blanket and you put something heavy on the blanket. It's distorting the fabric. And that means that everything else, if it tries to travel in a straight line, ends up traveling in a circle or in an oval shape.
Yeah.
So if you took a marble and you tried to roll it along a blanket and the blanket were distorted enough, the marble would start going in a circle or in an oval shape. And that's what was happening in Earth's vicinity.
Yeah, I understand that. And I've seen all the documentaries with the rubber sheet and the bowling ball analogy, and the marble goes around it because the rubber sheet is distorted. But if I drop your book, if I just go boom like that and it falls, it's just falling because of gravity. But it doesn't seem like the rubber sheet with the distorted space-time applies to a falling book here. Are they the same thing?
Well, that would be, so basically, Earth has is causing a distortion in the sheet. And when you're just dropping a book, you're not giving it any initial speed in the direction except the direction of Earth. So basically, you're helping Earth out by dropping the book. If you just let it go without even like pushing it, you're still not creating any kind of initial speed that is right angles to Earth's gravity. Only time things travel in an orbit is if they have an initial speed that is right angles to the gravitational well. So if you imagine some kind of well or funnel or sink, and you take a marble and you give it an initial speed going in the direction of a circle, it's going to keep going in a circle. And that's because of two factors. Its original inertia, which is it's a tendency to move in a straight line, and gravity. And those two counteract each other, and that's what creates a circular motion. If you just took a marble and place it very gently on the side of a funnel, it's just going to roll toward the center of the funnel.
Okay.
So the reason the moon is traveling in a circle around the Earth is because it originally had some kind of speed. And that's because, Earth and the moon started off, we believe that they started off as the same object. The moon was possibly torn off from Earth, or they started as the same unified object, and they both have their own motions. Earth is spinning and the moon is rotating.
Right. Yep. So while we're on the topic of huge questions like that, then how do you define time?
Well, in the Einsteinian perspective, time and space are all part of the same entity, and they are time is something that's frozen, according to Einstein. Einstein once said, "For us believing physicists, the past, the present, and future are all illusions. That you really have nothing to do with time," which is very comforting. He told that to the widow of one of his best friends, and he's upon his best friend Besso's passing, he said, "The past, the present, and the future are all illusions," and that's comforting. If you think about somebody who's passed away, you can think, well, in some part of the universe, they're still around.
There are
other physicists.
I know that quote. I always wonder if he was just being nice and trying to be comforting, or was he making a deep statement there?
I think Einstein genuinely believed that the perception of time was an illusion. So some physicists believe that real time is like space, that it's something that's just out there, and that humans just have some kind of illusion that we're moving forward in this system. And but that is a little bit problematic, because all our experiences are that time moves forward. So it's hard to say, well, that's an illusion, because that's something we live with. It's hard for us to step out of that and say, well, we're really, this is just a phantasm. This is just something we're dreaming, that time is moving forward.
Is this something related to the block universe, where if you could step outside of it, it's just one long, say, rectangular block of space and time, and you could slice through it at any moment if you were a deity or something and step into that particular space-time?
Yeah, so if there was some kind of alien creature or divine creature that could step out of the block universe, they would see the past, present, and future all as a single thing, and they would see people born and die at the same time and know exactly what would happen to them. So there are several different problems with that, though. in quantum physics, you have an element of chance or randomness. So you don't really know the future in quantum physics because there's a chance element. Unless you imagine there's a version of quantum physics called the parallel worlds model, where every time there's a quantum event, time forks. And then you can sort of imagine a time that's frozen, but you have all these forks that are frozen, almost like a map where you have all these junctions in the road, and those junctions are there in the map, and you can travel along one of them or another one, but they're still there. So that's one way of reconciling a block universe with quantum physics, which has all these options. But if you don't believe in parallel universes, if you believe in just a single universe, then quantum physics says we really can't know the future because there's an element of chance to the future. And that's one problem with it. The other problem is just that our own perceptions are that the past is gone and the future is unknowable. How can we say that there's some alien creature out there that could be different? You know, it's a big hypothesis to say that there are deities or alien creatures that can see everything. We just really don't know that that's the case.
So Laplace's demon that knows the motion and location of every particle, that's not possible, as we understand the universe, compared to Laplace's own time.
Right. So Einstein was a believer in that kind of strict determinism, but quantum physicists don't believe in that kind of determinism, strict determinism, except possibly for what's called the wave function, which is the fundamental quantum entity. The wave function is very abstract. We can never know the wave function, every aspect of the wave function at once. If we try to tap into the wave function and say, well, what's the position of a particle exactly, then we don't know the velocity of the particle, the speed of the particle exactly, because the wave function does not reveal all at the same time. It reveals only some aspects of things at the same time, and we can never know the wave function completely.
By the way,
it's kind of abstract.
With your understanding of all this as a physicist, are you personally a determinist, or do you believe in free will, or some kind of compatibilism on the free will determinism debate, or have you written about any of that or thought about that?
Well, my gut feeling, my intuitive feeling is that free will is out there. I guess I kind of believe, my intuition is that consciousness is something real. On the other hand, that's my intuitive feeling. I have no scientific proof for that. I'm not a dualist. I don't think consciousness is a separate substance. It's just that it's hard for me to see a way you can scientifically quantify consciousness. How can you develop an algorithm or some kind of mechanistic thing that says, you know, I exist, and know that mechanism is for real and really believes in its own existence? You really can't. The only way we know that we have consciousness is our intuitive feeling, and it's really hard to imagine being able to simulate consciousness.
What if it's just what if it's just a brute fact of nature? It just exists. That's it, and we can go no further. What Thomas Nagel called one thought too many.
Yeah, well, that goes back to, you know, what we're originally talking about, like our desire for a theory of everything. But it might be the case that there are several theories, maybe not several substances, but maybe there is some internal logic to consciousness that does not follow a mechanistic logic, which is certainly a possibility. People are trying to understand consciousness on the basis of quantum physics, but I don't really see any of those efforts as successful.
Roger Penrose and Stuart Hameroff have this, you know, theory of consciousness arising in the microtubules of neurons. To which, you know, my physics friends used to say, well, that's not possible because it's a macro, wet, warm system and quantum effects don't happen there. But now, according to Hameroff, there is evidence that quantum effects happen at macro, warm, wet environments or something like that. But again, at this point, I don't really understand that science at all.
It's something that's worth exploring, but I don't really see that there's been a huge amount of progress in trying to understand consciousness. So there seem to be these open questions that are very, very hard to explain using science. And I'm willing to live with that, because there are enough interesting questions in science to be solved that can be addressed through science.
Yeah, and back when Fritjof Capra wrote his books, The Tao of Physics, and I forget what the other one was called, and as if quantum physics is spooky and weird, and consciousness is spooky and weird, so they must be connected somehow, and that maybe free will comes out of quantum randomness or something like that. But Dan Dennett pointed out that would not give you free will. That would just be another element of randomness that you have no control over.
Yeah, it's hard to imagine that our thoughts have anything to do with randomness, or our actions have anything to do with randomness. But it's interesting because Einstein had this ongoing debate and dialogue with a physicist named Max Born, who was one of the founders of quantum mechanics. And Max Born strongly believed in free will. So he was an agnostic, and he really believed that that we should be able to decide our own fates, that nothing should tell us what to do. He rebelled against the idea that there could be any divine being, even a non-personal divine being, telling us what to do. So when Einstein said God does not play dice, meaning God meaning kind of nature in some ways, Max Born said, why would you say that? Don't you believe in free will? Don't you want us to have a choice? Otherwise, we're in an authoritarian society. It was during kind of the rise of authoritarianism, when the age of Mussolini and so forth, when he was talking about this, kind of like, well, don't we want to make our own decisions? And quantum mechanics, by negating determinism, is saying, well, maybe free will is out there. Born did not equate quantum randomness with free will, but he said quantum systems open up the possibility of free will, and was very strongly interested in that idea. And Pauli, as I show in my book, Synchronicity, was really interested in connections between the mind and matter, and he saw quantum entanglement as a way of trying to understand the mind, and he was interested in a unified theory of the mind and matter, and that's what he was trying to explore with the psychologist Carl Jung.
I love that. That whole section of your book is so interesting for what I do at Skeptic, because a lot of people sense that there's something else out there, another dimension, or there's some connectedness, like an ether or a consciousness ether, or like consciousness is pervasive throughout the universe. It's the ground of all being, as Deepak Chopra likes to say, and that and that somehow the spooky things that happen, coincidences and things like that, are evidence of this. And so here we get to the second part of your book on causality, understanding causality. It's kind of a signal detection problem. Any weird thing that happens in my environment likely has a straightforward cause. But if I can't figure it out, or if it's super complex, then it's easy to kind of intuitively slip into this other realm of, well, maybe that's that kind of quantum spookiness or interconnectedness or something like that. So I loved how, Jung and Pauli, and you developed that whole theme, because it does hit at a deeper problem of causality. Like, how do you determine causality? So let's go there. Most people start with Hume's definition of causality as constant conjunction. A happens, then B happens. A happens, then B happens. But as he pointed out, the rooster crows, the sun rises. Well, but we don't think that the rooster causes the sun to rise. That's an accidental, kind of pattern that isn't really there. And so his second definition of counterfactual causality, and I'll quote Hume, we may define a cause to be an object followed by another, or in other words, where if the first object had not been, the second never had existed. So if you silence the rooster and the sun rises anyway, then it wasn't the rooster. Okay. And so, this gets to the problem that your wife faces with determining causality in complex systems like societies or human behavior. It's not just A and B, A, B, C, D, E, F, G. There's 20 factors, and you have to control for them. And then so you have all these, multivariate statistical methods and all that. But getting back to kind of the simple Newtonian, billiard ball model of causality, the ball rolls, hits the other ball, and so on. The second half of your book shows why that model of causality is too simple. So walk us through some of the startling discoveries in the 20th century that said, and this is what thwarted Einstein too, that what we think of as this simple cause and effect is just not that way.
Well, I think what Pauli and Jung pointed out is that causality is a principle of the universe too, and that's what they were trying to explore, is causal connections. Not every connection is causal. And a good example of that is the idea of a spin system. So spin in quantum physics is a quantum property that seems to suggest, it's not really the case, but it suggests that on a fundamental level, particles behave like they're rotating in a magnetic field, and that the rotation can be either a counterclockwise or clockwise. So an electron can rotate counterclockwise, in which case it has a kind of a pole, a magnetic pole that points up, or it can rotate clockwise, in which case it has a magnetic pole that points down. And you know this because if you place an electron in a magnetic field, it either aligns with the field or counter-aligns with the field. So there are two possibilities, spin up and spin down. They don't really spin because they would have to go too quickly, but they behave in quantum physics as if they spin. So that's why we call it spin. Well, if you take two electrons and you put them together, you know that one of them must be upspin and the other must be downspin. And the reason is something that Wolfgang Pauli discovered. It's called the exclusion principle. Two electrons can't be in exactly the same quantum space. They have to have some fundamental difference between the two of them. So the difference, if everything else is equal, must be their spin states. So if one is up, the other is down. But if you don't measure the spin, you don't know which one is up and which one is down. So they're in a superposition or a combination of states between one of them's up and the other's down, or the first one is down and the second one's up. You don't know. Now, suppose you still don't know, you keep that hidden, and you separate the electrons indefinitely. So you separate them a mile away from each other. You still don't measure them. And then you measure the first electron by putting it in a magnet. And you orient the magnet in some direction. So let's say straight up. And the electron is going to respond to that magnet either by flipping up or flipping down relative to that magnet. Okay? Now, you could even turn that magnet 90 degrees, and it would still flip up or down relative to the way you turn the magnet. So it's always going to either align with the magnet or counter-align. Now, the remarkable thing about quantum entanglement is you immediately know two things. You know that the second electron will be aligned or counter-aligned in the same direction as the first electron. And you know that if the first one is up, the second one must be down. If the first one is down, you instantly know the second one must be up in the same direction, along the same line, which to me is absolutely remarkable, that some information is shared in an acausal fashion that both electrons have instant access to. They know the direction that the first magnet is oriented in, and they know what direction the first electron chooses. So that is not information being transferred. That's, in a way, shared information, shared over a distance. So it's an acausal connection, that there's no causal interaction between the two. Now, Einstein guessed, and other people like David Bohm, another quantum physicist, guessed that there was some hidden mechanism that linked the two of them. So that's why a physicist, an Irish physicist, John Bell, came up with a mathematical scheme to distinguish the possibility of hidden variables or pure entanglement over a distance. And that's called Bell's inequality. It's a mathematical expression, and by looking at a system, it either meets Bell's inequality or doesn't meet Bell's inequality. And if it meets Bell's inequality, then you have quantum entanglement. And remarkably, every test of quantum physics has been able to meet Bell's inequality pointing in the direction of shared information over a distance, which is what Einstein called spooky action.
Right. Yes, I love that phrase. And you mentioned a mile apart, but as you point out in your book, they could be on the other side of the galaxy.
Yes,
and therefore there's
right.
no this, because you have a discussion of the speed of light and how long it took to figure that out, and that was the finite speed at which causal factors can happen. This is obviously faster than that, so there's something else going on there. Now, what would be the medium? And this implies there's some sort of field through which this information is conveyed, but it's not. I'm not even saying it right that way.
Yeah, well, some physicists believe that space and time themselves are not fundamental, and that what's fundamental is something called Hilbert space, named after the great mathematician David Hilbert, who came up with an abstract space that could be any number of dimensions. You can have an infinite number of dimensions. And if we live in Hilbert space, then distances from our perception don't really make any difference, because you can have interactions, any kind of interaction in Hilbert space. That's an abstract interaction, and that measuring space and time are just, illusions for us. That's one possibility. And then the other possibility is that quantum physics itself is an illusion, that there's something more fundamental going on, which is what Einstein believed. And by the way, the term spooky was a reaction that Einstein had to being confronted a lot by claimed believers in the paranormal. So throughout his lifetime, people would say to him, "Oh, the fourth dimension, isn't that where ghosts live?"
Right.
Or isn't that where, the afterlife? And Einstein would say, no. The fourth dimension is something very real. It's very tangible. So then when quantum physics came along and say, wait a minute, you can have this interaction over a long distance, Einstein immediately associated with so-called psychic phenomena and said, hey, wait a minute, that's not real science. That's pseudoscience. Right. So Einstein believed that quantum physics was real, but that the explanations people were giving for it with entanglement and stuff were using the language of pseudoscience, and therefore there was something flawed about the explanation.
Yeah. Here I apply the skeptical principle that before you say something is out of this world, first make sure that it's not in this world, and first make sure you have something that actually needs explaining. So when people say, like this film, What the Bleep Do We Know? Where they're trying to use quantum physics to explain ESP or whatever, there's nothing to explain because people cannot read each other's minds. They cannot read the backs of Zener cards or playing cards. You can't. You can put them in a darkened room. They cannot remotely view objects on the other side of the planet or whatever. They simply can't do it. And back to the replication crisis we mentioned earlier. The handful of statistically significant experiments, the real ESP experiments, not the stuff you see on TV. Those have failed to replicate. And, the last one that kind of triggered the replication crisis was Daryl Bem's backward causality. Since you discussed backward causality in your book, I thought I'd mention that. That, again, he ran, I think it was 9 experiments, and only 1 or 2 were barely statistically significant. I mean, you really had to crunch the numbers to make it come out. And then, he file drawered the other ones and so on. So really, there's nothing to explain. We don't need quantum physics to explain it because there's nothing that needs explaining.
Well, as I show in my book, Jung was very interested in the work of J.B. Rhine at Duke University, that some of the so-called scientific experiments with mind reading, which have been much criticized. But Pauli was kind of willing to, even though he was very skeptical about many things, he was a very hard-headed physicist. He sort of became enamored with Jung's philosophy and was kind of like, well, let's just kind of look at Rhine's experiments, and he suspended his disbelief for a time. Now, he didn't do that indefinitely. As I found in my research, Rhine received a letter from Pauli in 1958, and he was very disturbed by the letter because Pauli said, well, I read that there were some attacks on your work, on the validity of your work. And Rhine opened this, and first of all, he realized that Pauli had already died. Oh. He knew that. And the letter, I don't know what was going on with the postal system at the time, but the letter took like months to reach Rhine in the United States. And Rhine got it posthumously after Pauli died. And Rhine was all upset, and he wrote to Jung and said, "Oh, I thought Pauli was interested in my work, and now he seems to be skeptical about my work. What's going on?" And Jung assured him, "Oh, no, Pauli wasn't really aware of what's going on. There's really no valid criticism of your work," and calmed Rhine down. But it was kind of interesting that in Pauli's final year of life, he seemed to be starting to become more skeptical about parapsychology and all these ideas, and returning to hard-headed physics, returning to the idea of unifying nature, and became, pretty cynical about things. Part of it, I might speculate, is that Pauli was a great believer for a while in symmetry, in the idea that everything in the universe happened symmetrically, which he began to start associating with images of symmetry in Eastern philosophy, like the yin and yang and all these ideas, and began to be interested in mystical ideas about symmetry versus physics and kind of equated the two. But then in 1957, experiments in physics showed that not everything in physics is symmetrical. There was a famous parity violation experiment conducted by the great physicist C.S. Wu at Columbia University, showing that some interactions are asymmetrical because of the weak interaction is fundamentally asymmetrical. It doesn't give you a mirror image. And Pauli was very disturbed by that. And he said that God is a weak left-hander, like that God is somehow has some favoritism there. Once again, meaning God is an impersonal force, but get the idea. But that kind of disturbed Pauli, and he began to think, well, maybe that these mystical ideas are not completely valid.
Yeah, but what do you suppose opened him up to the idea that they could be in the first place? Was it his friendship with Jung, or just a certain level of open-mindedness? Because the backdrop you give of Pauli, I mean, I knew him of his famous quip about "it's not even wrong." That was Pauli, right? Instead of a colleague's idea, it's not even. Yes, it's so bad, it's not even wrong. And that he was I didn't realize just what a tough-minded character he was. Didn't suffer fools gladly, as they say. And yet here he, at least for several years, he opened himself up to these possibilities.
Well, people are very, can be kind of gullible or malleable if they're going through a crisis. And Pauli, in the late 1920s and around 1930, when he turned to Jung, he was going through a severe personal crisis. First of all, his mother committed suicide because his father was having an affair with another woman. And Pauli was very close to his mother. And he was kind of at a loss for a while how to deal with women. Finally, he met a woman who was a cabaret dancer named Katie. And I guess he was interested in her, possibly mainly because of her appearance and so forth. They didn't really seem to have a fundamental personal connection. And she was interested in a chemist. And then she still continued to see the chemist while they were married. So they were married for less than a year. And then they had a, pretty bitter divorce after only about a year of marriage. And she ran off with the chemist. And he said, well, if she ran off with a bullfighter, I would understand, but just a lowly chemist. And so he was very upset with that. And then he began to wonder if he could ever have any relationships. And that's when he wrote to Jung on his father's suggestion. Jung took him in and assigned him to a young assistant female therapist to help him with his issues, named Erna Rosenbaum. And Erna took him in and said, well, discuss your dreams. Every night when you have a dream, when you wake up in the morning, write it down. And Pauli had more than 1,000 dreams, which is remarkable in its own right. I can't imagine remembering 1,000 dreams in the span of a few years. Perhaps I remember a few dreams each year or whatever, but thousands of dreams, or more than 1,000 dreams is pretty remarkable. But that those were interpreted eventually by Jung according to the archetype model. And Pauli began to think, well, maybe there's something to this, that maybe there are these ancient symbols that have some kind of scientific validity, and that perhaps we inherit these ideas, these archetypes, and that can lead to these invisible connections that we interpret as psychic phenomena, but are based upon this shared identity, this shared cultural identity that we somehow tap into.
Was the idea that dreams are a way of accessing this acausal universe that is there?
Yeah, so Jungian philosophy says that dreams are part of a collective unconscious, that we all have access to the same field of this collective memory of all the things that have happened to the human race over time, going back to, ancient Egyptians, their symbolism and so forth, that everything is somehow connected and that we somehow inherit it, which has never been proven scientifically.
Although you can see why the quantum spookiness is appealing to that model, that worldview.
Yeah, so it kind of equates entanglement, which has its own quantum field that we believe in, with this idea of a consciousness field, which has never been proven. There's as you said, there's really no evidence that people have ever been able to read minds and so forth.
Here's a thought experiment I had that just to show that I'm not always a hard-headed skeptic. Let's say it was possible that there were some experiments showing that people could read minds or the backs of Zener cards or whatever. And then it was discovered that, let's say, Hameroff and Penrose's model of neurons firing, and if I recall, the wave function collapses inside the microtubules of the neurons at the molecular level, and therefore the field could be read by some other mind, so that my neurons firing in a certain pattern could trigger your neurons to fire in a certain pattern at this quantum level, and therefore you could have similar thoughts to me, something like that. If that were true, that would no longer be extrasensory perception. It wouldn't be paranormal. It would just be quantum consciousness, or some branch of neuroscience or quantum physics or whatever we'd call it. So it could be.
Yeah, that's true. And in fact, Rhine, I don't really, think his methods are valid because they haven't been verified by other people. But he really aspired to be a hard-headed scientist. When he coined the term parapsychology, or used the term, it's recently been pointed out to me that someone else coined the term. But parapsychology is not meant to say this is something, spooky that's indefinable. Rhine fully thought that there was some scientific explanation for these phenomena, and was determined to find out the reason behind telepathy and so forth. He didn't really believe that this is kind of a spooky Halloweenish thing. Believed it's real
love
science.
That you referenced my friend Ray Hyman, because he's one of the legends in the skeptical movement, because he's one of the first to point out what I call patternicity, the tendency to find meaningful patterns in random noise, just by showing subjects flashing lights or a sequence of sounds. They'll find some causal pattern even if there is none there. So we tend to do that. Ray tells a funny story of when he was in college. He was a mentalist, and he a magician. He did card tricks and so on. But he developed some cold reading, what we now call cold reading techniques. But at the time, he believed he could actually do it, reading people. And then one of his psych professors said, next time you do a reading, say the opposite of what your intuitions are telling you to say, and see what response you got. And the response he got was, "That's incredible. You described me perfectly." And he's like, "Oh, it doesn't really matter what I say. They're doing the reading, not me."
Yeah. Well, someone remarked to me, pretty active on Twitter, and someone remarked to be something that I thought was interesting. They said that magicians are less gullible than scientists, that sometimes scientists are taken in by experiments, whereas a magician can immediately see the flaws, or someone who's trained with that. And I was thinking immediately of people like James Randi and Penn and Teller and so forth, who can immediately find the flaw in any experiment or a way around it. which is pretty interesting.
There is an idea in magical circles that magicians are more skeptical than mentalists. And one idea for this is that mentalists fall prey to their own confirmation bias and hindsight bias. And they begin to think, maybe I know I'm using these techniques, but maybe I'm able to get a few things that I'm not actually picking up on the normal way through the senses or something like that. I had a mentalist friend who used to work for the Psychic Friends Network before they went out of business, which none of them anticipated. and he thought he was picking up on stuff that he wasn't getting through the normal tricks of the trade. And I remember telling him, well, maybe it's confirmation bias, or even maybe you just don't know how you're picking up on, or it's just randomness and you're just remembering the hits and forgetting the misses. Anyway, it's an interesting idea.
Yeah.
But on archetypes, I've been thinking about archetypes ever since I met Jordan Peterson, and he started on his business about Jungian archetypes. He's kind of resurrected Jung in a way, but not in the context of like all the stuff you discussed, because you're correct. There's no scientific evidence that the way Jung thought of it exists. But in thinking about how evolutionary psychologists analyze like literary tropes and themes in the history of literature, their idea is that certain things come up over and over and over again in all great literature, Shakespeare and Jane Austen novels and so on, related to hierarchical social systems, love, anger, jealousy, power relationships. There's certain themes that come up because they are built into our nature, our human nature, or they're kind of the way the world is structured. That's a kind of archetype, I think, if you think of it more of a just sort of grounded in a materialistic science way.
Well, I don't know if it's really so much inherited aspects of our consciousness or our unconscious minds, but rather we have a certain amount of instinctive behavior, and human beings are going to have a certain range of actions based upon the fact that we're human beings, and our primal instincts, so to speak, delineate what kinds of behavior we'll have. I mean, I noticed that I have a dog, and the dog knows to do certain behavior, from instinct, and I think, okay, this is not some kind of collective unconsciousness among dogs. It's just there's something that's built into every kind of animal.
Yeah. Pauli, I think you said he was a deist, or maybe not even that. How do you, as a quantum physicist and your colleagues, think about God and some of these bigger issues like that? Is it reasonable to speculate and believe, or should you always be agnostic? In terms of ontologically speaking, agnostic. Maybe epistemologically, you make a decision practically whether you believe or not. But is it reasonable to be open to the idea there could be some outside force or something like that?
Well, I consider myself personally, my instinctive feeling, personally, I consider myself a spiritual person. But scientifically, I don't think that, anything, for example, in the Bible is correct, or any known theology is correct. So I'm pretty happy saying, well, I have personal feelings that are just based upon my experience with nature, or I go to some woods or something, or and I just feel a sense of oneness or a sense of peace or something like that. I mean, I don't know if that's an illusion or not. It's just an intuitive feeling. And then if I'm examining something scientifically, I'm not ever saying, okay, well, God enters into this. I completely exclude, including anything supernatural in experiments. I only look at natural factors. Now, that means that I am not anti-religion. I understand why people would want to believe in a religion. But at the same time, I'm not religious. Yeah. I tend to be non-dogmatic. It's hard for me to imagine that some book that's written by somebody or channeled by somebody has all the secrets of the universe. But I can imagine somebody opening their minds up and saying, while I was sitting, in the woods meditating, I came up with this idea or something just from my own
So you tick the box spiritual, but not religious.
It's hard to describe.
You tick the box spiritual, but not religious. But what do you mean by spirituality in this context?
I guess just a feeling that there's a feeling, and I emphasize the word feeling, that there's something out there more than the atoms and molecules of nature. But once again, it's just a feeling. I recognize that it could be an illusion. So as we were talking about earlier, I recognize that there might someday be a scientific description of consciousness, but I don't think it's going to be easy. So there might someday be a scientific description of why, if I'm walking through the woods, I have this sense of oneness. Why do I feel that way? But for me, it's real at the time, so I just kind of accept it.
I get that feeling when I go into astronomical domes like Mount Wilson telescope through which Hubble discovered the expanding universe, or Mount Palomar, which is magnificent. Even the Lick Observatory in San Jose, that was the first mountaintop observatory, with that huge refracting telescope. I think it's a 32-inch refracting telescope. And it's so well balanced, you could kind of move it with your own human power when it's not locked in. And, when you look through there and you're looking up at the sky, to me, it's like being in Shark Cathedral or something. It's like the sense of this is the machinery of cosmic wonderness or something like that. To me, that feels spiritual without it being spooky or supernatural.
Yeah, I mean, a lot of people have like a sense of wonder. And, when you're faced with nature, when faced with, the sky, or I remember the first time I visited New Zealand, and I went to the South Island, and I was staying in a youth hostel on the South Island of New Zealand in the middle of nowhere, no cities within many, many, many miles. And I went out at night and looked up at the sky, and it was a completely alien sky because I'd never seen the Southern Hemisphere sky before. And I could see the Milky Way absolutely clearly. I mean, it was just out there, this cloud of stars, and I could see, famous stars that I couldn't see in the Northern Hemisphere, the Southern Cross. I was just absolutely blown away by that, and I definitely felt, the sense of awe and wonder.
Yeah, I'm attracted to the idea of the Mysterian mysteries, that there's mysteries we can never solve, not even in principle, because our brains aren't big enough, or we just conceptually we cannot conceive of them correctly to answer the question, or maybe there's just an epistemological wall that we hit. We can't know, like, what was there before time began. You can't even ask that question, like, what's north of the North Pole, as Hawking famously said. Do you sense that 500 years from now, physicists will go, oh, now we got what is where the origin of the universe is, or what dark matter is, or whatever? Or do you think 1,000 years from now we'll still have grand mysteries that cannot be explained?
Well, there's Gödel's famous incompleteness theorem, saying that no reasonable mathematical system is complete because there's always a question that can't be answered with a true or false statement. For example, this sentence is false is neither true or false. Right. It's a paradox. So every mathematical system has a paradox, unless it's so trivial, trivial mathematical system. But any kind of realistic mathematical system has something that can't be solved. And I kind of believe that since we're experiencing nature, there must be some things about our own experience, about our own consciousness, that might not be able to be solved without us being able to step out of ourselves, to step out of the fact that we're conscious beings. So they might be indeterminable in the same way that unless some alien race came along and say, hey, wait a minute, you foolish humans, you don't really realize what the real reality is.
Right.
But as long as we don't encounter these aliens, we might not be able to know what the real reality is.
Someone like an alien Einstein that says, okay, close your eyes and imagine the two lightning bolts, or some thought oh my God, we completely misunderstood this. But, But like my response to theologians who, push this boundary back further because they want you to stop at God. What was there before? What banged the Big Bang? Well, it was the quantum foam fluctuation or whatever. Well, where did the quantum foam come from? Well, it came from a virtual particle. Where did the virtual particle come from? Came from, what? At some point, they want you to stop and say, well, that's where God did it. But, why can't we ask, well, where did the God person thing come from? What caused that? And, and their answer is, well, you have to stop the causal chain somewhere. Well, yeah, but maybe you don't.
But even those who believe in God as first cause might not accept that the Bible or any kind of scripture has authority, because in my mind that's a completely different question. If you say, well, I can see somebody arguing, well, there must have been a first cause somewhere. Yeah. Okay, that's a logical argument that's hard to refute. But at the same time, then they say, okay, well, all right, so then we have to believe every word of the Bible literally. And then, okay, well, where's the logical step that leads one to say, like, okay, well, you need to believe that. And even those who say, okay, let's believe in all of this literally, then they might say, well, okay, there's this description of the apocalypse with the four horsemen. Yeah. Well, that symbolizes something. Right. They say, well, I thought you said it was literal. Well, it's literal in its symbolism.
Well, while we're talking about theological arguments, so what is your response to the fine-tune argument, say the multiverse, and there's multiple universes, to which the theologian says you have no evidence for that? That's pure faith. You scientists made up this multiverse idea to account for this fine-tunedness or whatever. How do you think about that particular set of arguments?
Well, fine-tuning is kind of a tricky thing because there is a range of parameters that could lead to a universe with life, and then you think, well, okay, if things were extremely differently, then we wouldn't have a universe with life. And some people bring in the anthropic principle and say, well, then we wouldn't be here to talk about it, and try to kind of narrow things down that way. But I'm not sure if we need to kind of say, okay, why are all the constants, why are all the factors exactly the way they are? It doesn't seem like it's something we really have to worry about too much.
Really? Yeah. Okay. Yeah. In other words, you're sort of saying that's just the way it is.
Well,
but as I understand it, the multiverse is not made up by physicists to explain the fine-tunedness. It's a derivative of the equations or the predictions from certain models, right?
Yeah. So if you believe in the multiverse, from the sense that you think that like anything can happen, you say, well, okay, the universe started off in a completely random state, and we wonder why it ended up being the way it is now. Well, there are all these alternative universes out there that didn't quite evolve into the way things are now. So I see validity to that. I guess when I say not to worry about it, there are people who say, well, the universe could have started with any dimension, and we sort of ended up as 3 dimensions plus time. Well, how do we know that the universe could have started as any dimension? So, it's not clear to me that the universe had to start out absolutely chaotic. Maybe there's certain factors that the universe started out with that have been retained, like, for example, the dimensionality and so forth.
Right. Man, super interesting stuff. Well, Paul, we've been going well over an hour. I loved your book. I love thinking about these big questions. You end with a section here, cautiously embracing the acausal. I love that subtitle. Mm-hmm. While avoiding the selection error of assuming every coincidence represents a veritable acausal connection, we need not veer in the opposite direction and stick only to purely mechanistic causal explanations for all of science. Bell's inequality and modern methods in quantum Measurement theory show how to pursue long-range acausal connections scientifically. Wormholes and the complex connectivity of space-time and general relativity show that even in non-quantum physics, we must address the possibility of systematic violations of the notion that cause must precede effect. Wow. So, I mean, I kind of get a sense at the end, I really need to keep an open mind because we really don't, there's a lot we still don't know about these fundamental questions of cause and effect.
Yeah, that's right. So we don't understand why some things are causal and some things are acausal. It's kind of a mystery. Like, why do some things transpire at the speed of light or slower, and other things can transpire instantaneously? I mean, it's almost like the universe has these two channels of operation. And that's a really exciting question in physics, trying to reconcile those two.
I kind of almost feel like we're at that moment when Einstein came along in 1905 with his 5 papers. Like we're awaiting this like big revelation that could happen at any time. Maybe it'll happen at CERN or when they put the space telescope up, or who knows what. What could happen? Yeah. So it's a good argument for living a long time just to see how it turns out.
Yeah, these are exciting days for physics and discovery, and be interesting. But there might be, as we talked about, some mysteries that remain mysteries because we're not sure if a theory of everything will necessarily, include everything in the same way. That maybe there are different theories for different systems. One theory for general relativity, one theory for acausality. We like to believe that there's a theory that's all encompassing, but might not be the case. Just like we like to believe that the universe started completely randomly with anything possibly could happen, but it might be the case that the universe had certain preferences, and we just have to say, back to the fine-tuning question, you might say, well, why the universe start out the way it is? Well, maybe it just happened to start out the way it is, just, and we got lucky and we got life.
Yeah. Wow. That's great. Well, thanks for writing this book. What's next on your plate for big projects?
Well, I'm working on articles, and I'm working on a new book to be revealed next year.
And, give us a hint.
Working on articles.
That's okay. You don't have to. It's all right.
Related again to history of science.
Oh, good.
But I'm not superstitious in many ways, but I like to talk about books when they exist in the real world and accessible. So
that's a good policy.
But
I agree.
I like to move, moving forward with my books, moving forward with articles and things like that.
Well, Paul, thanks for coming on the show and thanks for your work. I really appreciate it. Really interesting stuff.
Thank you. My pleasure. Really enjoyed that.